All right, let's get rolling. Shut up. Let's get rolling. How'd the homework go? Any of you run into the situation where you're like, we're only writing 10 lines of code. Why do I have 50 errors? Missing semicolon, a capitalization here and there. It's good. You want to run into those sooner rather than later, because that'll help you make less mistakes along those lines. I wonder why we have so many people online today, but whatever. All right. Well, and for future reference for those people who are online, if you log into Zoom using your Concordia credentials, you do the login that says SSO, you won't get put in the waiting room, so I won't have to keep clicking the button to let you in. So maybe do that for now on, and that'll help you in other classes too, because you only get put in the waiting room if you show up as guest. All right, so let's see. Homework assignment was to do like a countdown thing. What did I say? From 100. Okay, so 100 to 1 or 100 to 0, but showing every 10, something like that. Okay, so let's go and look at that. Get this. There we go. All right. So what I'm going to do here is I'm just going to gut my current program. Start with that empty guy here. All right. So is that, you see that good? Big enough? All right. So we want to do something some number of times, right? So we're going to have a loop. We talked last time about some of the different kinds of loops, right? We have while loops, we have for loops. We mentioned for loops kind of lend themselves to counting type problems, even though we could certainly do this with a while loop. I'm going to go ahead and do this with a for loop. You know, maybe we'll look at a while loop afterwards, but I'll do it as a for loop. Remind me, what is one of the advantages of a for loop over a while loop? What did we see last time? Okay, well, that's one of the reasons to use it. A for loop, you know how many times to use it. Go ahead. Okay, one thing is more concise. Everything's kind of sucked into the kind of the syntax for the loop. So visually, it's more concise, but that also comes with a caveat, a kind of a rule associated with that. We talked about variable scope. Remember variable scope last time? So it effectively says, where can I access this variable? And with our while loop being less concise, we had defined our counting variable outside the loop, which means it was accessible anywhere in the scope where it was born from that point forward. Whereas with the for loop, which is more concise, the variable gets defined inside of the loop. It's part of the syntax of the loop, which means its scope lives and dies with that loop itself. So given this particular situation, not that a while loop is wrong, you're not going to lose points if you use the while loop, but in this particular situation, with our countdown, that's kind of this throwaway variable, right? It's something, we're just starting it at a number, we're going to walk it down to a 1 or a 0, whatever I said. And you know, when we're done with that whole countdown thing, that number, that variable we use to remember the current count is like a useless variable, right? We don't have a need to use that again. So we might as well go ahead and just let it die off so we don't have these unused variables floating around. Okay, really that has two reasons behind it. One is the historical reason, that is, well, you know, memory used to be really expensive, yada, yada, yada. We talked about the whole Y2K bug and all that stuff. Used to be really expensive. So we should only use the computer's memory for as long as we need to. So if you're done with that variable and you don't need to use it anymore, you might as well give it back to the computer so somebody else can use it. kind of a crappy argument today because we have so much memory and it's cheap. Okay, but our better argument today, probably from a programmer convenience, a quality of life perspective, is that when we're writing loops, a lot of times we'll use like, quick variables like I or J or K, that aren't overly meaningful, but it allows us to then use that variable again a little bit later in the program without having to invent new variable, throwaway variable names. So you can have 20 different for loops in your program that each operate on a variable called I, because each time through that variable died when that loop ended. So later on, you can just create a brand new one and you have a variable called I again for counting. And that comes down to when you're using variables just to control a repetition, not the variable being meaningful later on in the program. Okay, so we're going to go ahead and we're going to write a for loop. So for int I, so and if you didn't want to say I, you can use you can say int countdown. And we start at 100. Is that where we started at? Okay. And we what was the bottom number? I say countdown to 1 or countdown to 0? 0. Okay, so we're going to keep going as long as countdown is greater than or equal to 0. All right. And then what do we want to have happen to countdown each time? We're going to say, yeah. See, since you're not logging in online, every time I click the button, I'm unclicking my my website so that I can't type again until I click. So log in with your SSO on Zoom for now on. All right, so each time through, I'm going to say countdown is equal to countdown minus 1. All right, I know some of you did a little bit of a shortcut thing, since the actual question on the homework was, could leave room for a little of interpretation. Maybe you just counted down by 10, 100, 90, 80, 70. Tactically, that does meet the requirements of the assignment. Wasn't what I intended, so I'm going to do it the way I intended. So we're going to count down by 1 each time. Okay. Now we're going to start off by showing every number. All right. So, we're going to kind of build this in little pieces. So I'm going to start off here. We're going to do cout countdown carriage return. Okay. So we'll go ahead and run this, and we should get a 100 all the way down to 0 displayed to the screen. Okay. So go ahead and run that guy. We see our 100 all the way down to 0. All right, so we're part of the way there, right? So what I said is we only want to display something every 10 numbers. So we want to display the 100, the 90, the 80, and so on and so forth. Is that accurate? That's what I asked. Okay. So we conditionally want to display something. So I only want to do this line here sometimes. So I'm going to wrap this inside of an if statement. I'll leave the Boolean expression out for a second. We'll build it in. So conditionally, I want to do something here. I want to print it out. So now I have to say, well, what is the condition? Well, I want to do it every 10 times. So now you're kind of thinking about this as a puzzle. Now, I know some of you stumbled upon the modulus operator, which I'll introduce today, but that's not what I intended for you to use either. But it's okay, because you kind of did your choose your own adventure thing. You did some research. All these things are things that you're going to, get thrown at you. But bottom line is, I gave you a little puzzle to solve. And as long as you ultimately solve the puzzle in some sort of reasonable way, even if you count it down by 10 instead of count it down by 1 or whatever, it solved the problem. But I really wanted us to practice if statements and that kind of stuff. So I only wanted to do something every 10 times. So what I'm going to do here is I'm going to create another variable. I'm going to initially do it outside of the loop, and then I'll show you how you can actually bring multiple variables into the loop. So we're just going to call this guy int temp. We'll start temp off at 0. Okay. So we're going to say if temp is equivalent to 0. Double equal sign for equivalence. If temp is equivalent to 0, go ahead and print it out. Every time through the loop, we're going to say temp is equal to temp plus 1. So the very first time we come into this loop, we saw that we created a variable up here called temp. It started off as 0. Very first time through this loop, is temp equal to 0? Yes, it is. So we'll do a C out countdown. And then temp becomes 1. As I have it written right now, from this point forward, temp will never be 0 again, right? So I'm just going to get number 100 printed out here. So there's my 100. Also not quite what we want, but kind of testing the boundaries as we go, right? All right, so now what I really want to have happen is every single 10 times, we reset temp to 0. All right, so after I add 1 to temp, I'm going to ask the question, if temp is currently equivalent to 9, so 0 to 9 would be 10 times through. If it's currently equal to 9, then I'm going to go ahead and set temp equal to 0. So I'm using this variable temp as kind of a little trap, you know, kind of trips up the loop, you know, and so I'm counting from 0 to counting up from 0, but every single time I hit a 9, I reset it to a 0. So the next time through, it'll trigger this if statement. Oh, I need to do 10 because I'm adding 1 to it right beforehand. So it would have been 9 the last time through here, then 9 becomes 10, so I have to ask if it's 10. So there's our 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. All right, so is that one way of solving the homework? Again, these are just puzzles, right? At this point, there isn't necessarily one correct answer. In fact, I'm guessing most of you didn't necessarily do it this way. All right. Now, another thing we could have done is, like I mentioned before, we could have subtracted 10 from this thing up here. And then we could have, copy that. Could have gotten rid of all that stuff. And now the loop starts at 100, counts down to 0, subtracts 10 each time, prints every single time through. There's our 190, 80, 70. That one's maybe a little bit of too much of a shortcut. You didn't get to practice with if statements and things like that, but technically you could make it work. Okay. So let's, now I'm going to show you something else you could do. So one of the reasons we're using a for loop here is, besides it being a little bit more concise, is these variables also live and die with the loop. Okay, so that means at the end of this for loop, if I were to try to print out the value of countdown, it's going to scream at me. Countdown was born inside the for loop here. This is where we're defining it when we give it a type. So it was born right here. It was given an initial value of 100. It survived as long as this for loop was still going. But as soon as we failed our Boolean expression here, as soon as countdown was no longer greater than or equal to 0, we fell past this for loop, and any variables that were born as part of this for loop are now gone. So when I get down here, line 28, it's going to scream at me and say, hey, I don't know about a variable named countdown. Never heard of the guy. Make sense? Now, you could make your for loop behave like a while loop. I could define countdown before the for loop, not even give it an initial value. Let it get its initial value here in the for loop. I mean, I could have given an initial value of whatever because I'm resetting it right away at the beginning of your for loop. But I can bring it into existence up here saying, okay, I ran out to target. I bought a little container to hold something. I'm just going to kind of set it here because I don't have my thing to put in there yet. All right. That's what it means to define a variable without a value. I got it, but I haven't used it yet. I haven't put anything in there. Very first thing I did inside my for loop, I put something in there. But now, since I defined that variable outside of the for loop, it will still be available outside of the for loop. So there's my -1. It counted down to 0, right? Is 0 greater than or equal to 0? It is. Do all this stuff again. 0 becomes a -1. Is -1 greater than or equal to 0? It is not. Fall past the for loop, print out whatever countdown currently is, which was -1. Make sense? All right. Now, if we're going to write it this way, we would probably say, well, that's kind of a waste of time to write that as a for loop. Because at that point, we have stuff spread all over the place. So we could have just rewritten this guy as a while loop. So we could say while countdown is greater than or equal to 0. And then at the end of our loop, make sure you're reducing the value of countdown. So now we just turn that into a while loop. Define our couple of variables before the while loop. Start countdown off at 100. As long as countdown is greater or equal to 0, do all this stuff that we did before. Make sure that we do adjust our variable here, right? If we don't adjust our variable, this then becomes an infinite loop. So I'll go ahead and run this again. You'll see it's going to print out the line 28 right here. I forgot my semicolon. Reading your error messages. All right. So there's my 100 down to 0 with the -1 printing out afterwards. Now, if I forgot to decrement count here, if I forgot to subtract 1 from it each time, this is now an infinite loop, right? Countdown started at 100. Is 100 greater than or equal to 0? Sure. Do all this stuff. Loop back up. Is 100 still greater than or equal to 0? Sure. Do all this stuff. Loop back up. Is 100 still greater than or equal to 0? Okay, we're stuck in an infinite loop. Make sense? Okay. Infinite loops are typically bad. I'm going to say typically bad because there will be an example in this course at some point where we will purposely put something into an infinite loop with the intention of breaking out of that infinite loop. Let's call it for right now magically. All right, because we don't have enough context for me to tell you that. But sometimes you might just decide, I want this guy to just sit and do something over here forever until somehow I intervene until it just stops doing that. Okay. But for right now, we want to have the mentality, and it's really a pretty true mentality, that infinite loops are bad. Okay? So when you write a loop, it says repeat this stuff until this condition is false. At some point in your loop, you should probably have some value changing that will eventually make this condition false. Make sense? Right now, we don't. Right now, our countdown started at 100, and it never changes. And 100 is always going to be greater than or equal to 0, forever. All right. So there's a while loop version of this, this guy. Back up a little bit here. I'll go back to my for loop version. I'm going to go ahead and bring countdown back into the for loop. So now its scope again is part of that for loop. But I'm going to say, you know what? So we know this is going to be an error again, right? Never heard of countdown because countdown was born inside the for loop and it died when that for loop ended. So we expect this guy to be a problem again. Go ahead and run that. See it screaming at us, never heard of countdown. It was not declared in this scope. All right. Any questions why this guy is not available here? He was born inside the for loop, so he died when that for loop ended. So when we got to this line right here, that means the for loop has finished. Our Boolean expression finally ended. We no longer have access to that variable. Good news is we didn't really need that variable out there because it's kind of a throwaway variable. We're just using it to count down. The reality is that temp is also kind of a throwaway variable, right? Well, what we can do in here is we can say, we can define temp inside of the for loop as well. So if you were to diagram this, we go and put this in our syntax for loops. Okay, for loop is the word for, all lowercase, opening parenthesis. Then we have a comma delimited list of vars. We'll call it var definitions. Even though we technically saw you don't have to define a variable in there. You could define it previously and then give it a value inside of there. But in terms of typical use of a for loop, you're going to define one or more variables inside of that first little section before that first semicolon. Make sense? So you would give it the type, followed by the variables, and I don't think it lets me do this in C++, but let me just confirm. Yeah, it doesn't like that. So what does that ultimately mean? It means that all your variables have to be the same type here. You have one opportunity to say what kind of variables you want to define. And really, most of the time, you're only going to define one variable. 99.9% of the time when you write a for loop, it's going to be around a single variable. Do something 10 times. Do something 50 times, whatever, okay? So really what we're doing right here by creating two different variables in here is not a common use of a for loop, but it allows us to kind of see that whole scoping thing. So we're kind of drilling into it a little bit. All right, so we can define more than one variable as long as they are of the same type in here. They don't have to be in the same type if you've predefined them before the for loop. You know, you could have a char and an int or something like that if you did it before the for loop. But when you're defining it in the for loop, you get in C++, you get a single variable type. All right, so I've defined two different variables of type int. Countdown starts at 100, temp starts at 0. I'm going to keep going as long as countdown is greater than equal to 0. So this center part here, this is a single Boolean expression. Booleans being trues and falses. All right, we're going to go ahead and just give a quick definition for Boolean expression. This is any expression that boils down to a single value of true or false. Now, there's that line, there's more than meets the eye here in this sentence. It's any expression that boils down to a single value of true or false. As beginning programmers, you might glance at a big, complicated line of code and immediately assume that it's going to do more than one thing. So that's why I'm saying here, if it boils down to, it resolves to one value. So you could have a very complex Boolean expression with ands and ors, like the number's got to be less than 10, and it's got to be even, and it's got to be a multiple of, whatever, all these different things. But when you resolve it all out, it actually is just a single value of true or false. So don't get fooled by a line that looks complex. You have to go through the mindset of resolving it, decide what does this actually boil down to. And if it boils down to true or false, then you could point to that guy and say that is a Boolean expression. And Boolean expressions live inside of if statements. They live inside of loops, because we use them as our stop cases. An if statement uses a Boolean expression to determine should we do something or not, because we are conditionally doing it. If statements happen once. We ask the question, we either do it or don't do it. We have an example of that right here. If this Boolean expression right here is true, if it's true that the current value of temp, so we're going to resolve temp to whatever its current value is equivalent to 0, then we want to do that. If temp is not equivalent to 0, if that's false, we will not do this. So we're only conditionally printing out that line. All right. So if statements do something once and they let us conditionally do something. Loops do something for as long as that Boolean condition remains true. As soon as that Boolean condition becomes false, the loop's over. And we move on to the next line of our program. Okay? But there's only one Boolean expression, because that's our fail case. This loop keeps going until this breaks, until this boils down to false, that single Boolean expression, regardless of how complex that expression looks. Lastly, change your variable values. Literally, we actually only have to have the Boolean expression in there. We could write this code such that this stuff comes before the for loop, and this stuff happens at the end of the for loop. We could write it that way. We haven't defined any variables here. We haven't modified our variables here, but instead we defined them beforehand and we modified it here at the end, which is when this would have happened anyways. We still got the same program, except now we changed the scope of countdown and temp, right? Countdown and temp are now accessible outside of the for loop starting at line 15. So we have them available inside the for loop, but as soon as we hit this line right here, we still have access to them because they were born outside of the for loop. Make sense? So when we talk about scope, that's what we're talking about. Where can we access that variable? Similarly, we didn't take advantage of, as she pointed out, the concise syntax of the for loop, because that's really one of the main benefits of the for loop is, we're just doing something some number of times. That's usually when we're looping. We can just kind of put it all into one little package and it just works. Plus, in a lot of these programming things, it then lets you minimize. So that for loop ends up being kind of a one-line thing. Once you have your code working and you don't need to look at it anymore. So it also ends up being concise for writing your code and you have less stuff hanging on the outside. All right. But when we look at the for loop like this, where we haven't put anything in that first section, we haven't put anything in the last section, you start really questioning why you chose a for loop, even though technically it works just fine. Because really, what is this? This is a while loop that looks like a for loop. Just change that word to while. Get rid of our couple of curly braces or couple of semicolons, and now it's a while loop. Make sense? So this guy still runs. There's our, whatever our countdown. All right. So as a general rule, I would say it would be pretty questionable programming practice to ever write a for loop like this, unless you're doing it for a very, very, very specific reason. And at that point in time, you're probably an experienced enough programmer to know that this is weird, but you have a good reason for it or something like that. All right. But generally speaking, you should never write a for loop that looks like this. Use all of the space saving abilities of your for loop and use the 3 different parts to define your counting variable, write your Boolean expression, change your counting variable. That's the 1, 2, 3 punch for loops. All right, makes sense? All right, questions about any of that? We kind of wrote the homework in, I don't know, what, 4.5 different ways or something like that as we kept moving stuff around. All right, so now let's introduce something else. So we've seen for loops, we've seen while loops. I haven't shown you do while loops yet, but I've told you they exist. Mentioned that they are kind of like the secondary thing, because do while loops behave differently than while loops and for loops in that the body of the loop executes at least once, where a for loop does not. If I come back to my loop here and I move my, let's just get this back to a roughly reasonable for loop. Put the pieces back in there. All right. So we're going to say when I run this, still works fine, right? Everything is now concise inside the for loop. So notice that that's my entire program right there. I minimize the for loop here. There's nothing outside of it. So this thing's kind of all self-contained. Concise. I like that word. All right. Not really a major benefit, but it's kind of like the equivalent of cleaning up your room at home. You know, you want to have a kind of a tidy house, not too much stuff, especially as your programs start getting longer and longer and longer. Having stuff formatted nicely and encapsulated in the right places might start paying some dividends. All right. So right now this runs, we get our, 100 down to 0. But what if I started this at -1? Effectively a waste of time, right? Countdown started off at a -1. This loop is going to keep going as long as countdown is greater than or equal to 0. Is -1 greater than or equal to 0? It's not. This guy fails the very first time. Sometimes we like to build like the really impressive things and just it's completely useless. It's kind of like when you buy something from Amazon because it was on sale and you never open it. We have a couple Blink cameras at our house like that my wife asked for, and we still haven't cracked open the boxes. They've been there about 6 months. So in this case, this is perfectly legal code. Syntactically, there's nothing wrong with what we've written here. But logically, we know that if I started countdown off at -1 and this loop keeps going until this is false, and we happen to notice that that's going to be false the very first time through, maybe kind of a waste of time in the context of what we've written here, but this is legal. I'll run it. The program just doesn't output anything because we never get into the body of the loop. That makes sense? While loops behave the same way. So while loops and for loops are called pre-check loops, meaning we ask the question, the Boolean expression, we ask that before we ever execute the body of the loop. Do while loops work differently. They will do the body of the loop at least one time. And then they ask the question. So it could fail the second time through. But if this was a do while loop, we would end up going through one time, even though countdown started off at -1. And then we'd fail out of the loop after that. And that's not a very common occurrence, but I mentioned that it's not something you'll write very often in your code. You don't often write do while loops, but they actually exist in one place all the time, and that's with authentication. You have to give the program your username and password at least once for it to confirm whether or not you logged in correctly. And then if you gave them a bad username and or password, it'll yell at you and ask for it again. Make sense? So authentication tends to be something that has to happen at least once. So do while loops, I guess, exist, but they've existed since the beginning. They just do behave differently than for loops and while loops. From a practical perspective, 99% of the loops you ever write will be while loops or for loops. All right. And early on, as you're, getting your programming experience under your belt, you might just decide that you're more comfortable with one of those loops versus the other. And that's okay. I wouldn't try to force yourself into a for loop if just because it's a little bit more concise. If some of these, like, the semicolons and stuff in here just start feeling intimidating or something. If you like the pieces being individual, like here's my variable, here's another variable, here's my while loop with a single Boolean expression in it. If that's just more comfortable for you, do it that way. Once you get more experience, then this won't be as intimidating when you start getting extra symbols to forget that gives you more error messages or something like that. Okay. I'm never going to take off points if you use the for loop when it could have been a while loop, or you use the while loop when it probably lent itself to a for loop. It doesn't matter. All right. Really. When you get more experience, you'll make the correct choices because it will no longer be intimidating. Right now, your focus is on getting comfortable with the weird stuff and make yourself less error prone. All right. So questions about any of that? All right. So now, show of hands. How many of you had third grade math? You get the two people. I'm in the wrong room. Favorite part of third grade math was what? Long division. Remember long division? Where you had the something, remainder something, right? So, you remember long division. I'm even going to draw it right here. We have to go to my awesome picture drawing abilities here. So we're gonna go. Oop, I need some lines. Ooh. Remember that guy? Oh man, so good. All right, so we're gonna say we'll keep it simple. We're gonna say 7 divided by 3. All right. So how many times does 3 go into 7? 2 times. So what do? We write 2 up here, right? Then 2 times 3 is 6. We need another line. Seven minus 6 is 1. And where do we put that 1? We write it up here. We say remainder 1, right? Remember that guy a couple minutes ago? So 7 divided by 3 using long division, we're gonna call this guy integer division. Looks kind of like that, right? So it's 2 with a remainder of 1. So our question here is, from a programmer's perspective, how do I get the 2? How do I get the 1? How do we write some code that lets us get those individual pieces? in case we're interested in them, which, by the way, you're going to be interested in them way more often than you think. Most of you haven't used long division in years, right? Because now if you take 7 divided by 3, what do you get? You get 2 point something, right? That's math. You get the decimal point, you go out to a certain number of whatevers, move on with life. But sometimes you need this, and you're going to sit there and say, well, I've made it for the last 15 years and I really haven't. I haven't needed it that much. So in any case, you will in programming, and actually some of our most advanced encryption algorithms are based on this. It's actually pretty interesting. So in any case, we want to know programmatically, how do I get those 2 pieces? So let's go and look at that. What I'm going to do for the moment here is I'm going to save this. Let me just make sure I left it in a good state. Oh, I have not, because it's still start that guy off at 100. There's my countdown. That solved the homework assignment. We're good with that. All right, so I'm going to go ahead and hit share on this. And I will. Here, what I'll do is. I put it in Slack. So you have a snapshot of the solution to the homework sitting in Slack there. All right, so now let's go and look at this long division stuff. So go back in here. I'm going to go ahead and gut my program, give myself a starting point. So we're going to say int a is equal to 7. We're going to do double. Here, I'm going to give it some better variable. Int num is equal to 7. Double, call it num div, is equal to 7 divided by 3. See out num div. Run that. We see we get our, oh, 1 second. I'm going to start off as a double. Oh, you want to debug it yourself? Let's see. I hard coded a 7 in there instead of put my variable. But now I want this guy to be a double. All right. So I created my original variable named num. I said I want to be able to store it with decimal places. So we made it a double. Even though I just put a 7 in there, it's stored as 7.0. Then I created another variable called num div, and I set that equal to whatever num currently equals, which is 7.0 divided by a 3. And then I displayed that answer. That's what our calculator would give us, right? We punch that into the calculator, would give us 2.33. All right. So now, just put some comments next to that. I'm going to say int num is equal to 7. Int num div is equal to num divided by 3. And then we'll go ahead and output num div. So I stored num as an int. Num div is also an int. And I'm doing integer division here. And we see we get our 2. So as long as we're working with an integer type, not a double type or a float type, an integer type, we can get that 2 using normal division. But how do we get that 1? We're going to say int num remainder is equal to num mod 3. So the percent symbol is the modulus operator. All right. And then we'll print out numDiv, which we've already seen was a 2. And then we're going to print out numRemainder, which should be the 1. So there's our 2, remainder 1, using the modulus operator. So modulo, sometimes it's called modulus operator, percent symbol returns the remainder of an integer division. Slash returns the whole number portion of an integer division. So when we're doing long division or integer division, we can extract the 2 separate pieces using the modulus operator. Make sense? All right. So how could we have incorporated this into our homework assignment? Let's go back here. I'm going to say for int countdown starts off as 100. Keep going as long as countdown is greater than or equal to 0. Countdown is equal to countdown minus 1. We're going to ask the question in here. If countdown mod 10 is equivalent to 0, we'll output the current value of countdown. So there's our 190, 80, 70, blah, blah, blah. The right output. Well, let's walk through this and see what's happening. I know this loop is going through 100 times, right? Nothing's changed with my loop there. I'm counting from 100 down to 0. But I'm still conditionally displaying the current value of countdown. When am I going to display it? When this Boolean expression is true. When the remainder of taking countdown divided by 10 is equal to 0. Another way of putting it is when the current value of countdown is evenly divisible by 10. So if countdown, let's do some scratch paper over here. Number evenly divisible by 10. Let's say countdown started off at 100. Is 100 evenly divisible by 10? The answer is yes, right? 100 mod 10 is a 0. If I did long division of 100 divided by 10, 10 goes into 100 10 times with a remainder of 0. Make sense? Then it reduces to 99. Is 99 evenly divisible by 10? No. 99 mod 10 is equal to what? How many times does 10 go into 99? Whole, 9 times. Because if it went in 10 times, 10 times 10 is 100. It's bigger than 99, right? So 10 does not fit into 99 10 times. 10 fits into 99 9 times. 10 times 9 is 90. With how many left over to get us to 99? 9. So if I did the long division of 99 divided by 10, I would get 9 remainder 9. That makes sense? So 99 mod 10 gives me a remainder of 9. Is 9 equivalent to 0? Nope. So this will fail. This is false. So we won't conditionally print this out for 99. What about 98? How many times does 10 go into 98? 9 times with a remainder of 8. 97? 9 times with a remainder of 7. 92? 9 times with a remainder of 2. 91? 9 times with a remainder of 1. 90? 9 times, no remainder, right? 10 goes into 90 10 times. 10 times 9 is 90. We don't need anything else to get us to 90, right? So it's a remainder of 0. We'll get into that if statement. That makes sense? Now, this is related to our number conversion stuff. We talked about this. So if we go we'll call this A mod B. We're going to say for all positive numbers, A and B, the result of A mod B will be some number between 0 and B minus 1. So any value mod 10 will give you a result of 0 to 9. Any value mod 14 will give you a value of 0 to 13. Any value mod 3 will give you a value 0 to 2. Make sense? Base 8 holds the values 0 through 7. Base 10 holds the values 0 through 9. Base 16 holds the values 0 through 15. 0 through 9, A through F. So modulus is going to be involved with our pattern when we go and write the code to convert numbers between bases, because it lets us walk those exact same steps, right? I need the legal values of octal base 8 are 0 through 7. So that means if I take some number and I divide it by 8 and I look at the remainder, I'm going to get an octet, as long as I'm thinking about it in terms of conversion, number conversion. Make some sense? So this slide here is kind of an important thing to remember when you need something to happen without having to reset a value. If you think back to our first solution today to the homework, what did I do? I had 2 different variables, right? I had my counter going from 100 down to 0, and then I had that separate variable temp that I used to keep track of how many times has it been since the last time I printed something, right? And as soon as that got to 10, I zeroed it out. I just reset it to 0. Right? I used the second variable to keep track of when I should print, because I conditionally printed only when temp was 0. Make sense? Just kind of puzzled it, right? Okay, this isn't something that you memorize. This is something like you're sitting there with a, almost like a Rubik's Cube in front of you or something like that, a logic puzzle, and you just kind of think through it and say, okay, well, well, what can I kind of create to get my output that I want, even if it's somewhat Frankenstein-y, right? You know, I would say that first solution we had today with the 2 different counting variables, that was a hodgepodge Frankenstein type solution, but hey, it worked. You know, they're only looking at your output when somebody's running your software. They're usually not looking at the code behind. All right. So modulus is something that we're going to be able to use for a lot of different things. So throw that into your toolbox. Okay. Now we can do integer division as long as we are doing, now we can do long division as long as we're working with integers. And long division can sometimes be helpful for us for certain kinds of problems. Okay. Questions about that? So now let's talk about functions. And I'm going to throw in parentheses here, methods. So functions are reusable chunks of code that we write once and can call multiple times with different inputs. Okay. Methods are what functions are traditionally called in object-oriented languages. Synonym. You know, if you wanted to go back even farther, we had things like procedures in an older language, like a programming language called Pascal, which was created for teaching years and years and years and years ago. Procedures were functions that did not return a value. Functions were functions that did return a value. And we'll look at that today. You know, that sometimes we call this reusable chunk of code expecting it to give us back a value. Sometimes we call this a reusable chunk of code just expecting it to do something. Our initial experience with that is, when is it giving us a value back that we can then do something with versus when is it printing something to the screen? Printing to the screen is for human eyes only, but we don't have an answer to go and do something with. All right. So historically, functions returned a value, procedures did not. Now we just kind of hodgepodge them into a single thing. It's a function. All right. And you've used functions before in your math classes. You've used the sine function, right? So sine has a mathy meaning behind it, right? You throw an input into the sine function, a single number, right? And it spits out crazy value, you know, based on the geometry, right? You know, opposite over adjacent over hypotenuse, you know, all those things for cosine, cotangent, yada, 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 right? So that's a function that you give an input to, and it gives you a different value based on what your input was. Okay. So if you go way back before Pascal, you get to things where they used to be called like subroutines. Okay. Any of those words all mean the same thing. Reusable chunk of code. We want to write it once, so it's sitting there on the side, and whenever we need it, we're going to call upon that guy, passing it the value we want it to operate on. If we want to take the sine of 30 radians, we'll pass it a 30. If I want to take the sine of 75, I'll pass it 75. The same math, the same function. I just passed it a different value, expecting a different result, or potentially a different result. Make sense? All right, so let's go ahead and let's convert our countdown into a function. All right, syntax for a function is return type followed by function name followed by opening parenthesis, comma, delim. Just let me do it. list of parameters. You can think of those as inputs. That's what parameters are. In fact, let's just say inputs here. Delimited list of inputs, but historically these are called parameters. Opening curly brace, do stuff, closing curly brace. Where return type is any type the language supports, or void if you do not intend to return a value. If we have one of those old school procedures where we're asking it to do something for us, but not give us an answer back, we would use void. Otherwise, we would put in the value type that we're expecting it to give us back. So let's look at an example of this first. So I'm going to go ahead and I'm going to write a function to add some numbers. So we're going to say int add nums. So the return type for this guy is going to be int. The name of the function, I'm going to call it add nums. All right. Naming convention, you can't have any spaces in here, but typically, this is something called camel case. Typically, functions start with a lowercase letter and then have uppercase letters in them, and the function name should kind of define what this function does. That's for human purposes. The language doesn't require it to be meaningful. You can just put your favorite 15 keystrokes next to each other if you want, and it'd be fine with that. But human beings like it to be readable. So I see a function here called add nums. What does it do? Probably adds nums, right? All right. And we're going to say it's going to, in this case, it's going to add two numbers. So I'm going to expect two different inputs. So we're going to say int num1, int num2. So if I give this function two different integers, it will add them together and presumably give the answer back to me as an int. Now, the thing I want us to focus on over the next few minutes here is the difference between a function returning a value and a function printing a value. Those are not the same things. All right, and we're going to do it as an exercise, but the reason I'm harping on that, it is a super, super, super common thing for beginning programmers to get confused about. Functions that return a value, like for instance, a sign function. If I had this thing was the sign function, and I threw a number at it, it would hand me back a value. I might not show you that value, right? I now have that value that I could use for something else. I could feed it into the cosine function or something like that. I could feed it, use it for another part of my program, right? As opposed to if this was the display to the screen version of the sign function, I give it a value and then it would show you the answer. But I wouldn't necessarily have that number to go and use for other tasks. Okay? So when we return a value, I could then choose to show you the value once I have it, right? I could print it to the screen. But when we return a value, the purpose typically is that we're going to use that value for another purpose, right? You toast a bagel, it pops out of the toaster. You're going to get that bagel because you're probably going to put cream cheese on it or something like that, right? You have an intended purpose for the result of your toasted bagel. All right. So it's going to return an integer called add nums, take two numbers as a parameter. We don't actually need another variable here, but I'm going to go ahead and give ourselves some extra variables just to spell this out. So I'm going to say int sum is equal to num1 plus num2. And then I'm going to say return sum. So this is a function that I just invented that I can throw two integers at, and it will hand me back the sum of those two integers. All right. Actually, just for a moment here, I take that out. You don't have to do what I'm doing here. I want to give you that state of the code with the modulus in it. No, whatever. Let's rewrite it. So there's code with modulus in Slack. All right. So I'm going to go ahead and gut main. Remember, all programs begin and end with main. So when I run this program, it's going to start at main and do what main says. So if I ran this program right now, what would it do? It doesn't do anything, right? If I run it right now, I get no output because main says do nothing. Forget about this guy here. We can actually even leave it out and just say void there. Oh, it needs it to be an int in C++, but I don't have to return the int. So I can do that. The rationale behind that is older programs that ran in like text-based systems like DOS, Linux, things like Unix. They usually, if something went wrong, they would return an error code. If you've ever been on a web browser or something like that and see like HTTP error 500 or something like that, if you went and looked that up, that has a meaning, like what happened, what bad thing occurred on this web server that gave me that error. The same thing existed years ago with our command line programs where it would usually give you a 0 if everything was fine. Hence the reason it had hard-coded in there, return 0. Or it might give you maybe you decide a 7 means that bad username or password, something like that. So you can return different numbers based on an error code. But the reality is modern day programmers, we typically don't think about our programs being run from the command line. So we're not looking for that return value. Not something we do as a modern day programmer, but that's what it's left over from, that whole return 0 thing. So in C++, it requires main to have a return type of int. And realistically, when we say return 0 down here, we're basically saying no matter what happens in my program, everything worked out just how I planned it, because you're always giving an answer of 0 even though nobody's looking, right? This would be something like if you ran this program and were wondering whether it did its job, you would just check its error code and determine whether it worked or not. But we don't do that anymore as modern day software developers. So technically that should be there, saying return 0 at the end, but to really drive our point home of everything begins and ends with main, I'm going to purposely choose to not return a value. We'll just let it naturally boil down to 0. It'll do it for us because that's the default value of int. But now we see that main is in fact completely empty, right? Nothing in there. So if I make the comment that all programs begin and end with main, and I ran this program and you look at the very beginning of main there and you see nothing, that means this program does nothing. Make sense? All right. So I want my program to do something. What do I want it to do? I want it to add some numbers. So I'm going to call add nums. I'm going to pass it a 3 and a 5. What's the output of my program going to be now? We're going to talk about why it's an error, but let's assume it wasn't an error. Let's assume it worked. The error is easy to fix. If you want the error to go away real quick, just move this above me, but then we'll talk about it. All right. So besides the error, what do you expect the output to be visually looking at this? Okay, well, as a human being, we look at that, we say 3 plus 5 is 8. But am I actually printing anything to the screen here? I'm not displaying it anywhere. I would assume that this guy here would boil down to an 8. But unless I actually tell it to put it on the screen, it's not going to show anything. I'll go ahead and run this. You'll see the error. It's going to say add nums was not defined. Does that look familiar to you? That's a scope problem. Remember? Why? I'm trying to use add nums here before I ever defined it down here. So I'm going to show you the quick fix, but it's probably not the right fix. I'm going to move that to before main. So now that error goes away, right? Because we've defined the function now before we went and used the function. So go ahead and run this. Program doesn't have an error now, but we see we had no output. Now I can say int answer is equal to that. And then I can say cout. Cout answer. Ooh, really. There we go. And now I'll get my 8. I called add nums, passed it a 3 and a 5. It returned an 8. I caught the 8 inside of a variable called answer. Then I chose to show you that answer. But I could also do other stuff with it. I can multiply it by 2 or do other things with that answer because my function gave me some stuff, right? But now I can reuse that chunk of code. I wrote add nums once. So I'll go ahead and I don't have to redefine answer. I'm just going to use answer to catch my next value. And I'll pass this guy some big number like that. Oop, there's got to be all numbers. And some number like that. I gave it different inputs, right? And then I'll go ahead and display that guy. So it kicks it down a line. I'll put the \n thing up here. I'm just going to steal this whole line. Run that. So now we've written that function one time, yet we've called it 2 separate times with different inputs and got different answers. If you want answers that you can believe, we can say like 9 and 2. Now you can add it in your head. So that should give us an 11. So there's our 8 and our 11. Make sense? All right. Now I mentioned this is probably not the right way to do this to get the error to go away. And that's because, as you might imagine, as our programs get more and more complicated, we might run into a situation where we have more and more functions. Well, what if we have one function call another function? So let's say that this function, the second function, calls the one before it, and that guy calls the function after it. So these functions might rely on each other, and now there's no way for you to actually put one before the other one. Make sense? So the correct solution to this is actually solved in more modern programming languages. You can define the functions wherever you want, but then what you do is at the top of your program here, you just prototype it. You just give it the one-line header of it and say, look, at some point in time, you can expect to find one of these guys. I'm letting you know about it right now. So me putting this thing here lets the C compiler know that you're going to run into something called add nums at some point. I promise you, I will implement it. I'll give you the actual logic for the guy down here somewhere. But for now, just don't scream at me if you see one of these things. I'm giving you a fair warning. All right. Now it's going to be okay with this because I've prototyped it, even though I didn't actually give it its logic till later on. Make some sense? Okay. So for a little bit, you'd be able to get away with writing your functions just before main, because for a little bit here, we're probably not going to be writing functions that rely on each other. But pretty quickly, you're going to end up in a chicken or the egg problem where one function relies on another function, which relies on the other function. And there's no possible way you can get them both to be before each other. Okay? So start practicing with this guy. So what I'm going to do, again, as a reminder, the next time you're going to see me is like in 2 weeks. I'm going to give you a homework assignment for Tuesday. I'll also be giving you assignments while I'm gone with some videos to also watch that kind of keeps us progressing and keeps you practicing. So what I'm going to do for the assignment for Tuesday is have you rewrite today's assignment, but as a function, passing it different countdowns. Okay? Passing it different countdowns and different amounts of time, how often between. You know, do I do it every 10? Do I show it every 3? Something like that. Okay. So you can practice with functions, practice with modulus, yada, 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 yada. Questions, comments, concerns, bribes? You're still coming here on Tuesday because Waleed will be here to give you a crash course in quantum computing. And then I'll be messaging you on Slack and email with the links to the videos to watch. I'll make them shorter lectures, but since I won't have feedback going back and forth with people, I'll be talking to myself. But expect some assignments while I'm gone. Have a good weekend. I'll give you